Thank you very much, Jonathan.
You're 24, yeah?
Yes, please.
Nice to meet you.
Nice
How
to meet you
fun.
too. Bye.
Okay. Good afternoon, everyone. Good afternoon, everyone. Our faces are not smiling. Why not? Are we feeling cold? We are feeling cold, or we are hungry, or which of the above? Eh? Hunger. Are you hungry, or are you, when you say, what's the mixture of angry and hungry? Okay. Thank you, 24. My name is Jonathan. I work as a senior cybersecurity consultant. I have experience in Africa and also Europe and the US, helping organizations to protect their digital assets. So today, we're going to be looking at an interesting topic from firewalls to framework, cybersecurity for cloud-native applications. So we have seen the last presenter talked about a lot of applications. So how do you, secure those applications? So before I even go forward, with a show of hand, if you are a cybersecurity professional or enthusiast, can you raise your hand? Oh, okay, good. Okay, what about if you are a software developer, but you want to learn about cybersecurity? Okay, so we have more of cybersecurity professionals here, or software, or so the session is going to be a mixture of both. Either you have experience writing codes, software engineer, software developer, or any form of application development, or you're interested in the security aspect. So things like DevSecOps, SecDevOps, we've probably heard about things. Or you want to you're a software developer, you want to know how to secure applications more better, right? Instead of just writing codes and leaving them to be vulnerable to security risks. So let me just quickly share an experience. So it was just yesterday or day before yesterday, we were doing an engagement with one of the biggest banks in Nigeria. And those kind of things, before these banks release the applications to the market for every one of us to download, their mobile apps, their web apps, they call guys like us to come and try to pen test the applications, to try to break into those applications to see if it's possible and how we can recommend them to protect it. And 99% of the time, it is possible. It's something we've done before. So yesterday, one thing I see, which is something I'm going to talk about in this engagement I was doing with this bank, is developing an application, but putting your secret in the front end. I'm sure somebody is laughing there. Like, that's a rookie mistake, Abby. Or we don't know. Developing an application and putting your API secrets on the front end. That is very, very risky. So that's one of the things that I'm going to talk about today, how you can scan, how you can safely develop applications without leaving space for attacks. All right, so rethinking security in the age of cloud-native architectures. That's what we're going to be looking at. So just briefly, some of the things we're going to look at is around why traditional firewalls are no longer enough. So firewalls are network security solutions that's used to prevent internal applications from exposure to external threats. So those are firewalls. They can be either physical or logical forms of firewalls, right? So why are firewalls no longer enough? We're also going to look at cloud-native applications and the risk these cloud-native applications bring. So we see a lot of developers develop applications on Azure, on AWS, front door, different forms of DigitalOcean. Those are cloud-native applications. So what are the risks that these new applications bring? Also looking at DevSecOps principle, right? Before it used to be DevSecOps, but now it is now SecDevOps. So the difference is that you're no longer putting development before security. So now, it is advisable to put security before development, right? So that is why it is now SecDevOps, which is security, development, and operations, right? Because we found out that putting, the normal way, which is DevSecOps, you develop an application, and then you call in the security guys to say, okay, try to break this and see if it's possible. But that is not a sustainable approach because of course, security guys may not find everything, but when you build an application with security in mind, right, you are taking the proactive approach, right? You are mitigating the risk before they even happen. So that's part of what we look at today. Um, okay. Please, it keeps changing to this. Okay. Please, can we make the slides stable, please? Thank you. All right. So just more on what we're going to look at, why traditional security are no longer enough. The core risk in cloud-native environment, zero trust. So some tools, what are some tools, what are some framework that you can start using from today, right? So even though this is not a demo, but I'm going to give you some tools that you can start using if you're a developer or even if you are a cybersecurity enthusiast and you want to start looking at how you can involve security in your development approach. We're going to also see a case study, right, where you're going to run, a case study of something I did, which is run some security queries on an application, and it tells you the vulnerabilities that are in those applications and how you can also replicate those, and then an action roadmap, right? And also question and answer. So first, why are we looking at security? Why is frameworks, security of cloud-native applications important, right? Because now a lot of organizations now develop the applications on the cloud, right? Cloud adoption is now very faster. There's now innovation, right? We see a lot of organizations these days. The rise of fintechs has now become rapid, right? Almost every week now, or almost every month, we see a new fintech applications coming out in the market, doing different things, or even doing similar things. So there's that faster innovation, but this innovation is also leading to new attack surface areas, right? Because things that we're not seeing, 5 years ago, 10 years ago, we've started seeing them. It was just 2 weeks ago, or was it last week, that some nation-state attackers were able to engineer Claude LLM to perform automated attacks on organizations, right? So that is things that we were not even seeing like 5 years ago, like 10 years ago. Now, it is now easy to perform sophisticated form of attack because of the widespread of LLM. So that is why we have to look at how do we even ensure the security of our applications, right? Traditional firewalls, which are mostly physical, logical. So if you want to deploy a firewall, you buy a firewall box. Usually, if you're an enterprise solution, there's a firewall box, and then you connect it into your networks, right? And then you set some rules, right? Deny, allow, depending on the kinds of applications you want to have access to. There are some applications that are only internal applications. So if you're an enterprise organization, or if you're developing applications for either an enterprise or a small business, right? And you only want people internal to the organization to be able to access that application. So you set those on the firewall, and then you can restrict certain IP addresses. So that's kind of like the very basic use of a firewall. But it is not possible for a firewall to now do that on a cloud application because it is based on a cloud, right? And usually firewalls are mostly for internal applications. That is why it is very, very important. We see a lot of serverless functions. We see a lot of containers these days. I have this quote there that says, our infrastructure is no longer static, right? We are deploying containers, microservices, and serverless functions, each introducing their own unique risk, right? Serverless functions, containers, virtual machines that are not running on any host, right? So they have their own risk, and we must ensure that all of these two are protected from issues from different forms of cyber attack. Now, what is the evolution of security evolution, right? Security must evolve with architecture. So we've seen previously it used to be on-premise, right? Where a lot of organizations still use that model today, where they have a data center and then you have all of your racks and all of your appliances in the data center, which is the on-premise. So if you are familiar with the different cloud service models where you have the software as a service, platform as a service, and all of those other cloud service model. We have the on-prem, and then it moved to virtual machines, right? Where you don't necessarily need to host all of your applications on-site, right? You can run the same form of applications on a virtual machines because of scalability. I mean, you can set a virtual machine to scale based on need, right? But if you are running your applications on-prem, you have an infrastructure that you cannot scale. You need to buy a lot of more, data centers. You need to buy a lot of more or get more space in your data center. But if you are running an application on a virtual machine, you can set a form of load balancing to scale those virtual machines if you are having some form of higher traffic. Let me give you an example. So, for example, maybe Jumia now, we know it's December period, and they are doing sales. Right? For example, the guys at Jumia, the backend guys or the security guys or the infrastructure guys, they can, whatever their backend infrastructure is, if it is hosted on a cloud, on a virtual machine, they can set an auto load balancer that scales with the traffic. So maybe they say, okay, Black Friday is from 13th to 19th. And based on statistics, based on data, they know that people like to purchase either on the first day or on the last day. So this is data that you now give to your engineering guys so they can put those data in and say, okay, based on the expected traffic, this machine should scale, must replicate itself to be able to feed those traffic. Otherwise, the infrastructure will collapse. So that is auto load balancer, right? It can replicate itself, but if you are hosting on a physical data center, you cannot do that. You cannot run to the data center and say, okay, let's add more racks, let's add more storage. It's not possible. So that is why VMs are now very important. So we also see containers and also microservices. So every shift in architecture brought its own efficiency, so with new vulnerabilities. Firewalls worked for data centers, but not for ephemeral workloads. So workloads that you cannot necessarily see. You run these workloads based on different tasks that you need to do. So either maybe you're running some form of Kubernetes, or you're running some form of containers that are hosting some databases, or you're hosting some applications that are critical to your business. So Firewalls might not necessarily work for that. It has its place, but they need to be more innovative in your approach. Now, let's look at the shift to monolithic services. So we've seen the monolithic applications and microservices. So this is just documentation of what I've explained previously. On-prem to multi-cloud, static IPs to dynamic workloads, right? Where you have workloads that are not particularly assigned to a static IP address because of their unique nature. So an application that is readily configured to scale based on need. So that is dynamic workloads. And then firewall perimeters that are now becoming identity perimeters. So firewalls that we now understand to be static applications where you configure your rules based on what you want to deny. I've never seen any firewall configuration that doesn't have a deny all rule, right? Because the last thing in a firewall configuration is like a deny all, because you want to be able to deny every traffic that is not configured on that your firewall. So that is why every firewall would have a deny all rule. So it's based on its use. IT. Okay, why firewalls are no longer enough? Please, can we do something to this slide? Why it keeps breaking off? So why firewalls are no longer enough? These are things that we've discussed already. Ephemeral containers, serverless functions, east-west traffic in Kubernetes. Security must evolve from the edge of the cloud to from the edge of the code and pipeline, right? This is just a summary of everything I've been explaining so far, right? Security must move from the edge of the code must move from the edge to the code and to the pipeline, not just having it as an afterthought. It must be embedded in your code, in your entire pipeline, which is your DevOps. So DevOps guys, involving security from your continuous integration to continuous deployment, are always scanning your infrastructure to ensure that you are running a secure application. So the perimeter is no longer a place, it is now an identity. Previously, perimeter is your estate, what is within your estate. So that is like a place. Now perimeter is now an identity. Identity is something that you have control over. So that is how you should look at your perimeter now to have an innovative way. So what are the top threats in security? First is misconfigured cloud storage buckets, right? I think it was some years ago, there was a news about NIMC data breach due to an exposed S3 bucket. How many of us had the news then? So that is one of the very common security data breach for cloud applications, misconfigured buckets that exposes personal identifiable information, privileged information that should not get to the public, and that is very, very common. And even there's been several cases, not just in Nigeria, also abroad for big Fortune 500 organizations having this issue as well. So it's a very, very common issue. Hard-coded secrets and keys. I gave an example of this earlier. Coding your secrets, your APIs, your keys in the front end of your application. Over-permissive identity and access management rules, right? In your cloud solutions, you have rules based on the things that you need to do, based on which user that you're going to do. So, or applications that assume roles to perform certain tasks. So if you're developing an application, you can give it some certain roles to be able to assume those roles to perform some certain things. So if you're, for example, if you're running patches, right, you're using for example, in AWS, using the SSM, Session Manager, to run your patches. You need to configure it to assume some certain roles to access your EC2 instances. So, because it is not automatic. So, those kind of roles like that have some certain form of privileges need to also be monitored for, so that they are not over-permissive and they are not taken advantage of by a malicious attacker to perform some form of act against the organization. Vulnerable containers, which is also very common. And insecure APIs. So APIs, application programming interface, another very big risk. Insecure APIs, we've seen that very, very, very common. One of the things that we do is, we do stress tests for APIs. So we do API testing, where you test the API to see the kind of information that you can jailbreak it to give, that is not supposed to give. So that's something that's very common. So our backend guys here that are developing applications, APIs that connect with different microservices and different applications, ensure that you are also watchful around that. Lack of runtime visibility. You're not able to see what is running, which means that you don't know where the issue is, right? If you don't have visibility into your workloads, then you are not able to secure it. The one key principle in security that we usually say is visibility first, because you can only protect what you can see, right? You can only protect what you can see or what you have visibility over. Not just necessarily maybe your eye seeing it, but having that, okay, this is what I have in my estate, these are the workloads I'm running, these are the IP addresses, these are what they are connecting to, this is what is ingesting, what is integrating, what is consuming, and all of that. That gives you that, okay, if this application is consuming these workloads, then these are probably the risk that it can be exposed to. So visibility improves security. So that is why it's also one of the top threats in cloud security. Then supply chain compromise. So Supply chain is around your vendors, your third parties, and the likes. Now let's look at time is fast spent, so let's quickly look at security as a code, right? How do you now practicalize some of these things? We've seen the importance of DevSecOps. We've seen some of the top threats. We've even had some examples of how this can be an issue. So how do you practicalize it? Embed security into your CI/CD pipeline. Automate your vulnerability scans. So if you're running to run scans, one of the slides there, I have some YARA rules there. I can share this slide with you if you want. We're going to get there. To run automated scan on your workload, and it's going to tell you where you have some vulnerabilities on that workload. So it's also very important. Shift left, so start security at the planning stage, which is your SecDevOps. So I just put DevSecOps here so that we know it's something we are familiar with, but the right approach is now SecDevOps. So once you start thinking with security from the start, doing things like threat modeling. So every software engineer should know how to conduct a threat model, right? How to do a threat modeling. And a threat modeling is about looking at your application from an attacker's point of view, right? And there are different forms of threat modeling, but the one which I'm familiar and very comfortable using is the stride model. The stride model is how would an attacker break into an application? How would an attacker break into this application using this model? So the first S is the spoofing, tampering. So you can read more about it. So every software engineer, every person that is interested in application security should know how to conduct a threat model if you want to build secure applications. So let's quickly move first. So the first stage is the plan. The second stage is the code. So first stage is the plan. Second stage is the code. Okay. So build, test, and deploy and monitor. So after you plan, you write your codes, you build your applications, and then you test it, and then you deploy, and then you monitor. So this is the approach that you should take while building your secure application. So add security at checks at every stage. So let's quickly just move to the YARA rules because I'm out of time. I wanted to show you a quick demo. This slide decided to have his mind of his own today. So we see how to do this. You're using GitHub Actions. You can run Trivy. So Trivy is an application that you can run on your container images. Chekhov also is an application that you can run on your KICS or your infrastructure for infrastructure scanning. So these are some tools here, and it gives you alerts for any critical vulnerability. So if you run Trivy on your GitHub Action, if you run Chekhov on your GitHub, it can give you a list of vulnerabilities that it has identified on your code and tell you how to remediate those vulnerabilities, right? So that is the importance of that. Now, zero trust. Okay, let's just move. Zero trust. How do you implement zero trust on applications? So you implement your multi-factor authentication everywhere. You have restricted identity access management policies, and you also have policy hygiene. You also have security mesh, and you also have policy as a code. So you have your APA there, you have your gatekeeper in Kubernetes. Those are load Kubernetes here. You can use OPA and gatekeeper for your Kubernetes workloads. Those would give you an head start, which is to start with what you can control, which is access and identity. So access to your applications, you have to restrict it. You have to be very, very particular about access to your applications. Now, finally, what are some tools, what are some frameworks that you can use as an engineer, as a software developer, or as a security professional to ensure that you practice these application security principles in your daily life? So we see for image scanning, you can use Trivy, which I mentioned earlier, which scans your containers. So Trivy scans your containers. It also scans your infrastructure as a code, right? For your runtime, you can use Falco. Falco is a solution that can do behavioral monitoring. So you can use Falco for behavioral monitoring. And then for policies, so what kinds of policies have you written? And what kinds of JSON? So you write policies with your JSON. So sometimes you might do a mistake and allow a wildcard where you're not supposed to allow that wildcard, right? So you have to ensure that those policies, you can use OPA for, to Falco, sorry, for behavioral monitoring, and then OPA to ensure your security rules, and benchmarking for Kubernetes and CIS benchmarking. So those are frameworks that you can use. And then finally, for secrets management, you can use your AWS Secret Manager. You can use your, which helps you to store and rotate secrets. So you're not using static secrets. It's very dangerous to use static secrets during development because once it's taken advantage of, anybody can use it. But if your secrets are rotating in your development lifecycle, right, it's automatically generated. Even if the previous one falls into a wrong hand, it becomes obsolete. So that is the importance of secret rotation. So thank you very much. I hope this has been very useful. And let's see if there's any one question.
All right.
Okay.
Thank you very much, Jonathan.
Any question? Or it has been very clear? So if there's no, I usually assume when I make a presentation, if there's no question, it's either was very clear or very confusing.
So we want your questions to be very, very short and direct, yes. Because you've already raised up your hand. So let's get the mic to him. Just one. And please be direct.
Thank you for the presentation. During the conversation, you mentioned about firewalls. And I understand that they might be, so let me be clear. Are you suggesting that firewalls are a little bit obsolete or their use case has evolved over time? Or because the environment that we have now, we are more identity-based of the perimeter base that we used to have. And in those times, firewalls were very, very efficient. But with what we have now, do you think that firewalls are totally not efficient anymore?
So I'm not excluding the usefulness of firewalls. Firewalls are still very, very relevant. So they are still very relevant, but their use cases have a little bit evolved, right, based on applications. So what you used to use firewalls for, now for innovation, especially for cloud services. So firewalls are very restrictive form for protecting your cloud workload. So firewalls have their place, but if you're developing applications, especially containers, microservices, you cannot create logical rules for things that is not tangible. So that is why firewalls are not the best for those kinds of applications. All right, thank you very much, everyone, and enjoy your session.